Okay, so any function has a relative or local max when that function changes increase to decrease. So we are looking at f prime. I'm going to put some labels on here so it's easier to talk about. They've got x equal a labeled. I'm going to label x equals c. Another place might be x equal d. X equal e. F. G. And then b. So raise your hand if you can tell me. At what x coordinate will f prime have a relative max? Here's the definition again. F prime has a relative max. Sorry, any function has a relative max when that function changes increase to decrease. So at what x coordinate, Blake, does f prime have a relative max? D. So Blake votes D. Please raise your hand if you are voting with Blake. Two more, perfect. That's where f prime has a relative max. It's really this. The good news here is this. If the last problem made sense to you, this one should be a piece of cake because it is the exact same idea applied to a new situation. So we've got f prime. They're asking where does f have a relative something or other. So we don't see f. All we see is f prime. But again, Danica's chart is a quick way to remember how this works. So if we see f prime change it, so if f prime has positive values, f prime is the rate of change of f. So if f prime has positive values, that means f is going up. If f prime has negative values, f prime is the rate of change of f. So if f prime is negative, that means f is changing in a negative way. So that means f would have to be going down. We're looking for a relative max on f. We want to know when f changes increase to decrease. It means that's when f prime will change positive to negative. So hands up. At what x coordinate does f have a relative max? We know that f prime has a relative max here. That's where f prime has a relative max. At what x will f have a relative max? There we go. At what x will f have a relative max? No one.
I wasn't raised.
We're still looking. You're good. Keep counting. At what x coordinate will f have a relative max?
I changed my mind.
Oh, go Noah.
My money's on E.
Noah's voting E. Right there, f prime is changing from positive y values to negative y values. That means that's where f would have changed, increase to decrease. So we're going to type that out. How many knew that? Show me. Two more. Cool. I'm going to type it as a summary here. You already did. Hit right there. So right here is my little summary. Oh, it's the relative min one. We'll type the relative max one too. Hold on. Oh yeah, please, Josh.
So the positive and negative on the chart are if it's above the y-axis.
Correct. The way to think of it is like this, Jackson. When you look at Danica's chart, you are talking about the y values. So this column, right here it says f is increasing. That means the y values of f increase. This means the y values of f have a concave up shape. That can be tricky because that means the slopes of f are increasing. But if the slopes of f are increasing, that means the values, the y coordinates of f prime will be going up. If f is going up, that means every slope of f must have a positive value, which means the y coordinates of f prime must be positive. Is that your question? Two more. Let me type something real quick. Hold on. I type so much faster than I write. It's almost as fast for me to walk back here, type it, as it is for me to stand at the board and write it. So we'll type it. So f of x has a relative max at x equal, what do we call it, E, because f prime of x changes, increase to decrease at x equal E. And you can abbreviate increase and decrease on the AP test even. Questions? So hands up. Where does F, listen close so you don't get fooled. Where does F prime have a relative minimum? Hands up. Where does F prime have a relative minimum? Let's go, David.
C.
Which one?
C.
C. So C is where F would have a relative minimum, not F prime, but F. No worries. F prime is changing negative to positive at x equals C. So x equals C is where F itself would have a relative minimum. Okay? 2 for Davis. Where does F prime have a relative minimum? Where does F prime have a relative minimum? Let's go, Sophie.
Is it point F?
So at point F, that's where F prime has a relative min, because that's where F prime changes decrease to increase. How many saw that one? 2 more? Questions? We're good. So hands up who knows the answer to the question. What's the answer to this question? Let's go Tally. Tally, sorry. Which one? A. This graph of F that we don't see, we see F prime, and from F prime we know that F has one relative maximum at x equal E, and then F prime has a relative, F has a relative minimum at x equals C and x equal G. How many knew that? 2 more. Okay. Questions? Yep, there we go. Need to fix that to say and x equal. Second. Here we go. Madeline, please.
On the green thing you wrote, doesn't F prime not change increasing to decreasing? It changes negative to positive?
Oh, thank you. I messed that up. 2 more for Madeline. Thank you. It would be positive and negative.
From this point right here, this point right here. You calculate that average.
Excuse me?
Yeah, please.
I'm sorry.
sorry, I lost track. What are the two relative minima?
So, two more for Samuel. So everybody look. So notice one thing I'm going to do. I can't answer his question until I make it more clear. Otherwise, I'll answer the wrong question.
Okay.
I believe you're saying, where does f for f prime? Which one you want?
F prime.
So you want to know where f prime, is that what you said?
Mm-hmm.
So where does f prime, keep going,
The two relative minima.
oh, have a relative min? Okay, 2 for Samuel, but he's stepping in the trap. Let's see how many can see what trap he's stepping into. Look up. We've done it before, just do it again. You have to keep track of f and f prime separately and figure out which one you're talking about, which one you're looking at. Say it together as a class. What are we looking at? Say it. F prime. So if we want to know where f prime has a relative min, raise your hand, don't say it out loud. What are we looking for on f prime? Hands, come on. We want to know where f prime has a relative min. What are we looking for on f prime? Isaac?
Increasing and decreasing.
Right, Danica's chart really helps with that in my opinion. We're looking for a relative, dang, I don't want that. A relative min on f prime. We got to go see where f prime changes increase to decrease. If you knew that, give yourself 2 more. So Samuel, you tell me. This is f prime. Where does f prime change increase to decrease? Oh, sorry, decrease to increase.
Increase to decrease is between C and D and F and G.
So f prime actually changes increase to decrease right at x equal d. That would be where f prime has a relative max.
Okay, yes. So D is the relative max.
Of
correct?
f prime. Of f prime.
Okay. Yes.
But if you're looking for the relative max on f, that's somewhere else.
Of course.
That would be at E, where f prime is changing positive to negative, causing f to have a relative max, which is f changing increase to decrease.
If E is the maximum of
Relative
F,
max of, okay, so E,
not F prime.
yes, E is the relative max of f. Right here, f has a relative max at x equal E.
Then where would the relative minimum of F, not prime, be?
Perfect. So that's the red one. F has a relative min at x equal C, and also x equal G, because that's where f prime is changing negative to positive, which means that's where f will change decrease to increase, meaning f has a relative min at those 2 points.
F is the relative minimum of F, not prime.
So the relative min of f is that x equals C and also x equal G, just like it is stated here. Let's go over here.
So there are minimums not by the fact that, wait, no, I'm sorry. There are minimums by the fact that they go from negative to positive on the F prime chart, but not how sharply it goes from negative to positive, right?
The sharpness doesn't matter. Yeah, and let me say it back to you. So f itself has a relative min at the x coordinate where you will observe f
Okay.
prime changing negative to positive.
No, I just made sense of it. Okay, I got it now.
Please, Cora.
So I'm just wondering, are we looking at like point F, point D, and F to kind of figure out like where F prime is changing? Because the question is asking about when F is changing. So is there a point in looking at D and F?
So for this, 2 more for Cora. For this exact problem, there was no reason to look at this spot at all, and there was no reason to look at this spot at all for this problem. I was just testing to see how well you all understood the definition for future problems. Does that make sense? Yeah. For this problem, the only place I needed to look was right here. Get it off. I only needed to look here, here, and here. All the rest was just extra questioning to make sure you kept it straight. Cool, stop this video.